Welcome to our tutorial on conic profiles. First, let's activate the sketch command. Set the Y-plane. Now, let's undock the profile toolbar. And let's undock the conic toolbar also. The first element, we've got an ellipse. Let's select the center. In my case, it'll be the origin point. Down below, we see the major semi-axis endpoint, the major radius, the minor radius, and the angle definition areas. Let's select 30 millimeters on the edge vector. Lastly, we've got the minor semi-axis endpoint and the minor radius. And here is our ellipse. Let's double-click on it to make some more adjustments. The ellipse definition window opens. Here are our coordinates. Currently, we show the center point at the origin point. These values are grayed out right now because the ellipse shares the center point with the origin point. Let's cancel out for now and create another ellipse. Now let's double-click and you see that I'm able to adjust the center point values. Let me expand the tree. Sketch 1. Geometry. As you see, this ellipse has its own independent center point, but this one doesn't. Let's double-click. We can change the major radius. Let's enter 40 millimeters. The minor radius, 25 millimeters. Tab. The angle, let's enter 45 degrees and click OK. Now both radii have changed and the axis has rotated 45 degrees. Let's double-click on our ellipse. We have two tabs here for different coordinate systems, Cartesian and polar. Let's cancel out for now. Let's right-click Ellipse 2 and hide it. Ellipse 1, hide. Let's create a point now. Right about here, 20, 10. Now if I double-click on this point, in the Cartesian coordinate system, the location of this point is defined by two numbers, 20 millimeters and 10 millimeters vertical from the center point. The same position viewed in the polar system is defined by radius and angle. If I put an angle value of 0, for example, tab, you see the point moves right here. Let's double-click the point. In the Cartesian system, this is defined as a 0 vertical value, whereas the polar coordinate system defines the angle as 0 for this position. The polar coordinate system is especially useful when the relationship between 2 points is most easily expressed in terms of angles and distances. In order to express the same relationships in the Cartesian coordinate system, you would need to use trigonometric formulas. Much more complex. Let's cancel out for now. The next tool on the conic profile subtoolbar is the parabola by focus. First, I define the focus. Next, I define the apex and the start point, then the end point. Now double-click and the parabola definition window opens. Here we can enter values for the focus and apex points in Cartesian or polar coordinate systems. Let's cancel out for now. We'll right-click and hide our parabola. Our next profile is the hyperbola by focus. Again, first we define the focus point, next the center point, the apex, the start point, and the end point. Let's double-click on our hyperbola, and you see we can enter coordinates for the focus and center points in both Cartesian and polar coordinates. Let's cancel out for now. We'll right-click and hide our hyperbola. Our last profile is the conic profile. First, let's create two construction lines. Here's our second one. Now let's define the passing point. We'll double-click to open the conic curve definition window. Here is our start point. Here's our end point. And passing point, point 13. Tangent. Basically, these lines are tangent to this curve at corresponding points. We can also use the option tangent intersection point. And now both of these lines disappear and the point field becomes active. Now I'm able to select a point. Now basically what happens is that the tangent to this curve from this point and this point will intersect at this point. Under intermediate constraints, we have a parameter checkbox. What this means? If you take this point as having a value of 1, where the tangent and point intersect, and this point as a value of 0, basically, if I create a straight line between these 2 points, the middle will be right here. This value is the ratio which defines the passing point. Let's enter 0.75 and hit Tab. The passing point moves right here. The closer the passing point to the tangent intersection point, the sharper the curve will be. And correspondingly, the farther the passing point from the tangent intersection point, let's enter, for example, 0.25 and Tab, the smoother the curve will be. Here, instead of parameters, we'll use points. Here's our second point. Deactivate the snap function and put the second point right here. And as you see, the movement of this curve is restrained by the point that I'd placed previously. I'm going to place it here and click OK. We can still move this point afterwards. And this concludes our tutorial on conic profiles.